So, what do we remember about I? What is I? The square root of -1. Because can I do the square root of -1? No. We can't take square roots of negative numbers. But that bothered mathematicians so much, they invented I so they could. Like, seriously, that came from people trying to do quadratic formula, getting negative numbers and having to stop and them like, So they made up I so they could finish solving stuff. So I is the square root of -1, which means I squared is what? -1. I squared is the square root of -1 squared. So I squared is the only thing that when squared gives us a negative number. I cubed, it's the square root of -1 to the third. Or we could make that be -1, pull out an I squared. And the square root of -1, right? Like, can we see that? Or did I make too many weird jumps there? Because that one feels awkward. So it's -I. Because this is, hang on. I'm going to rewrite that, so if you started writing that, that's fine. Square root of -1 squared times the square root of -1. That a little bit clearer? This turns into -1. That's what we call I, so it's -I. That one a little bit clearer? So I cubed, that's the square root of -1 cubed, right? I can write that as square root of -1 squared times the square root of -1. Square root of -1 squared is -1. It all simplifies down to -I. Okay? Cool. I to the fourth, same thing. Square root of -1 to the fourth, that's the square root of -1 squared times the square root of -1 squared. So we get -1 times -1, which gives us 1. And then, hopefully, it's going to start, like, refreshing a little bit. It becomes a cycle. Because I to the fifth, that is square root of -1 to the fifth, I can remove or factor out to the fourth times square root of -1. This is 1. So this simplifies down to be just I. I can pull out I to the fourth. I to the fourth is 1. Right? I to the fifth is I to the fourth times I. Okay, so it simplifies down to I. It becomes this cycle. I to the sixth is the same thing. I could make this I to the fourth times I squared. I to the fourth equals 1. So this simplifies down to I squared. I squared is -1. So it becomes a cycle. It's always going to be I, then -1, then -I, then +1. And it's all about finding units. Whenever we simplify i's, we should be able to cancel out all of our exponents. It's always going to simplify down to I, -1, -I, or 1. It's always going to be one of those 4 options. So simplifying I is going to be a big chunk of what we do. Okay, so we're always going to have to simplify I down to the point where it does not have more exponents. Okay. Hi. Oh, more of these. Awesome. Okay, and hang on. Oh, that I was gonna say she's married. No, that's in here. Really. Yep, I got them both. Cool. Brianna. Okay. Is that for what I put up there? Huh? Mom ears. Careful how we respond. Huh? Don't cuss.
Oh, I get it now.
I have those mom ears. What the heck is what we were trying to say there? Yeah, what the heck? Remember, I have an 11-year-old. My ears will just whoop to whatever that is. Like Scooby-Doo. Ruh-roh. Okay, so we're going to simplify this. Remember, I to the fourth equals 1. So I want to pull out as many 4s as I can before I have to deal with the rest. So I could rewrite I to the 23rd as I to the 20 times I to the 3rd, right? Okay on there? The reason I want to do that is because I to the 20 I can put as I to the 4th 5 times. I to the 3rd, right? I to the 4th equals 1. 1 to the 5th is 1. So this whole piece just equals 1. Okay? I to the 4th equals 1. Yes? Yeah. That was what we just said. 1 to the 5th is just 1. So I to the 20th is 1. Okay? So all we're left with is I cubed. I cubed is negative I. So that's what we did on the previous page. You can also think of it as I squared times I. I squared is negative 1. So this becomes negative I. So our answer is negative I. That's our answer on that one. So it simplifies down to negative I. So pull out as many 4s as we can. I to the 4th equals 1, and it gets a whole lot of stuff out of the way. Okay? So let's look at the next one, 82. Well, I know that 80 is a multiple of 4. So I'm going to make it I to the 80 times I squared. Because I to the 80 is I to the 4th 20 times. But I to the 4th just means 1. And so 1 to the 20th is also just 1. So we get 1 times I squared. Negative 1. 1 times negative 1, and our answer here is negative 1. I to the 36. We could write that as I to the 4 times 9. I to the 4th to the 9th. Because 36 is 4 times 9. So it's just 1. You could, but pulling out 6 isn't going to be super helpful unless we remember that I to the 6 is negative 1. Negative 1 times negative 1 still gets us a positive 1. So it still works, but pulling out 4s is more helpful because 4 is 1 and it just disappears and gets out of the way. What's up? Tomorrow is The quiz tomorrow is sections 2-1 and 2-2. I'm pretty sure. Hang on. This is 2-3. I think. Hang on. Wait, is this 2-4? This is 2-4. Sorry. This is 2-4. Yeah. Yesterday was 2-3. So yesterday could be on tomorrow's quiz, but today is not on tomorrow's quiz. Today is on next week's quiz, next Friday. And then the chapter test is the next Friday. Like the whole test, the big test. Only 2 more quizzes until the chapter test. It's okay, we'll get there, I promise. Okay? Got it. Found it. All right. So now we have the negative 19. So whenever we have a negative exponent, this is 1 over I to the 19. Right? Negative exponent puts it in the denominator. Still going to simplify this the same way. 1 over, and I can pull out I to the 16 times I to the 3rd. Because I to the 16 is 4 to the 4th, right? So this is just 1 over I to the 3rd. This one give us some space. I to the 3rd is negative I. Right? Okay. Now we have a little problem. Because remember, I is a square root. We have a square root in the denominator. We got to rationalize it. So we're going to multiply by I over I. Because that is 1. A weird looking one. I'm going to change the view on this so you can actually see what's happening here. Extend down. So we can bring this up a little higher, okay? So I'm going to multiply by I over I. Because that's going to turn my denominator into I squared so that I can get rid of the I in the denominator because we don't like that. So what we get is I over negative I squared, right? What's I squared?
1.
Negative 1. So we have I over negative 1. Negative 1 is just 1. I over 1 is just I. So when they have the negative exponent, they are a little bit more obnoxious because we'll have to rationalize to get the I out of the denominator. Because it is not simplified when I is in the denominator or when I has exponents. So I needs to have not, I will scooch it up because I see a lot of people in the back doing the stretch. It is not fully simplified if I has exponents or if there's any i's in the denominator. So you got to rationalize it. Honestly, I think this is the hardest part of today, and there are questions on the homework where we're going to have to do like 4, like this, where they give you exponents and you have to fully simplify. Okay, so there is one on the homework like that, and it is number, let's see, I can get to my homework, 16 and 18 are very much like this on the homework for 2-4, okay? I think like that's the hardest part today is the simplifying of the radicals. Because after that, we're working with complex numbers, which we've done a bunch. In Algebra 2, we did. Complex numbers are the A plus BI. The picture on the bottom is like from your, like they have it in your book. Like you don't have to copy that down. It's just a quick refresh of the fact that complex numbers were outside the world of real. We are into imaginary numbers. Complex numbers aren't real numbers. This is when math starts to get weird. Because mathematicians are extra and couldn't tolerate the fact that they couldn't finish solving stuff. We worked with these guys a bunch in Algebra 2. And what we're going to do for the rest of the day is we're going to add, subtract, and multiply complex numbers. It's just like polynomials. It is just like multiplying x plus 2 times x minus 3. It's the same process. We just have to simplify I. Okay? So adding and subtracting complex numbers. It is no joke, just like polynomials, combine like terms. Combine like terms. So 3 plus 4i plus 2 minus 7i, combine like terms. If I'm adding these together, it doesn't matter what order we add things in. Oh, that is not a pen. 3 plus 2 plus 4i minus 7i. I can move things around if it helps us see what's going on. It does not matter. Combine like terms. So this one simplifies down to be 5, 3 plus 2, 4i minus 7i minus 3i. Okay, combine like terms. That's it. Okay, I told you, the simplifying I is the hardest part today. It is the hardest part today. The second one, minus 5 plus 3i minus negative 1 plus 2i. So I was going to say, you can think of it as distributing the minus sign. So we wind up with negative 5. See, I can. Negative 5. Yeah, negative 5 minus negative 1. Negative 4. Because that's negative 5 plus 1. 3i minus 2i minus 1i or minus I. It genuinely does not matter. It's combining like terms. Okay? Yes, sir. Yes, it should be plus 1i. Absolutely great. Plus 1i. That is an I. I don't know why it looks like a snail. Okay. Are we okay on adding and subtracting?
Yes.
It's combining like terms. We should be okay, but I know it's coming right after all the exponent stuff where it made my brain hurt. We're going to multiply them.
Oh my God.
Distribute. Or box it. Okay? So we're multiplying. 2 times 3. 6. Plus 2 times minus 4i. Minus 8i. 5i times 3 gives us plus 15i. And then I need one more color. 5 times minus 4i gives us minus 20i squared. Right? Multiply it out. Then we're going to simplify. Combine our like terms. 6. I have minus 8i plus 15i. It's going to give us positive 7i. Minus 20i squared. What does I squared simplify down to again? Negative 1. So negative 20 times negative 1 gives us plus 20. Now I combine that with my 6. 26 plus 7i. Okay? So we have to include the simplifying I, but very rarely we're going to have anything other than I squared. Okay? So there's our multiplying. That's what we're going to keep doing for the next 3 of them, okay? I'm going to give myself a little barrier over here so I can actually tell where they separate. Same process over here. We're going to multiply it out. -8 times -1 gives us +8. -8 times +2i gives us -16i. I times -1 gives us -1i. And I times 2i gives us plus 2i squared. See where all the pieces come from? Okay. All right. So then we're going to combine our like terms. And we get 8 minus 17i. I squared is the same thing as -1. So we have 2 times -1. 6 minus 17i. Okay? So they're not awful, but we have to remember about our simplifying I stuff in order to get all the way down. Okay? We're going to do 2 more of these together. Okay? So this is starting to combine things together. I've got some multiplying, I've got some adding, I've got some subtracting. Approach it how you see fit. I will recommend distribute and then do your subtraction. But you do whatever works for your brain. 6 minus 15i plus 7 minus 3i would be how I would write the next step. I distribute the 3 and then distribute the minus sign. That's what works for my brain. It is not the only attack you can have on this. But that's what works well for my brain. So combine our like terms. We have 6 plus 7, giving us 13. Yeah. And minus 15i minus 3i minus 18i. And that's our answer. Okay. Distribute, combine like terms. Okay. Oop. It's too easy, is that what we said? Well, we'll do dividing tomorrow. Okay. So we have, this one's going to have extra steps because I have I times this thing squared. So I'm going to do my exponent first. I times 4 times 4 is 16 minus 12i minus 12i plus 9i squared. If we need to write that out as binomial multiplication first, that's fine. If we can start to be able to do them closer to in the head or with fewer steps, it'll save us time in the long run. So I'm going to simplify inside before I start multiplying I through. But you could just distribute the I through here and go from there. But I like to deal with as few i's as possible. 16 minus 24i minus 9. Because that's 9 times I squared. I squared equals -1. So we have I times 16 minus 9, which is 7, minus 24i. Now I'm going to multiply that I through. 7i minus 24i squared. Right? I squared equals -1, so this becomes 24 plus 7i. I will make it bigger and higher. Because I saw the back doing the lean. Okay? So they do get a little weirder. Tomorrow we're going to work on what happens when we try and divide numbers with I in them. And then Monday we're going to play with square roots of negative numbers. So that we can simplify and get to the I from the number in the radical. Okay? Or from the quadratic formula when we wind up with a negative in the radical. So you can do 2, 4, 6, 12, 16, and 18 on homework 2-4. And that's all I have for you today. So you have 15 minutes. Oh my gosh. Time in class to work on homework. Shock. That very rarely happens in here, but you have it today. Okay? So work on it. We may wind up with time tomorrow as well, depending on how we're feeling about our quotients and stuff. But we also have that quiz tomorrow, so we don't have tons to talk about tomorrow.